Hello and welcome to York Universe, the Astronomy and Astrophysics program written and presented by students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I am Julie Tomei, and I am joined by Dr. Elena Hyde. Hey, Elena.
Hello, hello.
We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. if you're using Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 p.m. and 10 p.m. local Toronto time. Head over to yorku.ca/science/observatory and follow the links to OPV for online public viewing to join in the chat. For any questions or comments you have about our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca or connect with us on socials. On Twitter, our handle is @York Observatory. On Instagram, you can find us at York U Observatory, and on Facebook at the Allan I. Carswell Observatory, or Allan I. Carswell Obs. All our programs are free, but if you would like to make a donation, we certainly won't say no, and you can go to that same website, yorku.ca/science/observatory, and click on the button. We'll be monitoring the chat room for questions and post content. The current weather, I think, was a little bit blah where last time I was outside. How about you, Elena?
Yes, unfortunately, it is just blah enough that we cannot open the telescopes, and it keeps changing from a little rainy to a little snowy, which is actually terrible, and I wish it would stop. But if it was clear, there's a lot of great stuff out right now. We're having some wonderful winter skies. Saturn, Jupiter, the Pleiades, everything's getting really, really nice and high. And if only we could get some of that nice, crisp, clear winter air that a friend keeps saying exists, then we would be able to open up the telescopes and look at them. But for now, we'll have to peer in between the clouds with our eyes and keep the telescope closed.
Yeah, so archival images in the OPV tonight, but they are lovely images nonetheless.
Yes, it does show just how nice it can be when it does behave weather-wise.
Yes, well, that's what's wonderful about the online public viewing. It doesn't matter what the weather's like.
And I will say, just as a little advertisement for our YouTube channel, the online public viewing has been co-broadcast with York Universe for almost 3 years now, I want to say. So we actually have a lot of video footage going back in the archives, and it was just recently reorganized, so it should be very easy to find under online public viewing playlist, I believe. So if you are so inclined, you can investigate that playlist anytime you want on our YouTube channel.
Nice. It's true. In the past, before it switched over to York Universe, to YouTube, once it was over, it was over.
Exactly. Well, and we do actually have a good number of astronomy.fm episodes that were co-broadcast and captured on YouTube, actually. So we have a whole interesting little archival set, I should say. And everything is actually updated. All the episodes that we were able to get are now on the archive in the website as well. So if you want even more content from your friendly neighborhood Allan Carswell Observatory, that's the same website that Julie mentioned before. That's yorku.ca/science/observatory and then /outreach. We have everything up to episode 551 which was just last month. And we're only missing a small set back in 2019, which was, as you say, in the pre-YouTube area.
Nice. All right. Well, since we're talking a little bit about archives, let's
Yes.
jump into our space and astronomy history this week.
Speaking of images that are really awesome, even when they're still, we have This Week in Space and Astronomy History. So we're going to be jumping around a little bit, I think, today, but I'm going to go back not too long ago, or pretty long ago, I suppose, depending on how old you are. But December 6, 2006, doesn't seem that long ago to me. December 6, 2006, NASA released a set of very, very interesting images. And I do remember when these came out. These were the Mars Global Surveyor images that indicated not just water on Mars, but relatively recent water on Mars. So you have to remember back in 2006, as you were, we didn't have the Curiosity rover yet. We had Mars Global Surveyor, which was a U.S. robotic space craft, which was developed by NASA and JPL, and it was launched back in 1996. And it was, a mapping mission. And the cool thing about it is it was actually mapping the entire planet of Mars, and it was going through from the ionosphere down to the surface, mapping the surface again and again and again. And so if you take multiple pictures, well, you can see differences. And sure enough, this was a pretty big difference. So this was an official press release, December 6, 2006. You can still see it up on the JPL website if you're so inclined. And to quote JPL, this was the images that suggest water still flows in brief spurts on Mars. And these were little gullies. And basically what they did is they showed the difference in a little gully channel along the side of a crater as it appeared in 2001. And then again, when they had reimaged it in 2005. So this is why, of course, in astronomy, well, one of the reasons why we always say more data is better. Having a good image of Mars's surface doesn't tell you necessarily what's changing on Mars's surface. So having repeated imaging over time from 2001 to 2005, of course, people had to go through these images. So it took a little while before they realized that there was actually an appreciable change on the surface. This was a real new bright deposit. It actually showed up as a bright white on the picture. And they say that the strongest explanation for it was water. So some sort of subsurface water had built up, I guess, and pushed its way to the surface of Mars. The surface of Mars being not so nice as the surface of Earth for water. As soon as liquid water hits the surface of Mars, it starts to do something called sublimate, which is go directly into a gas phase. It's a very low pressure, cold atmosphere environment, and it has hostile conditions to water, liquid water as we know it. So it can't exist for long, but as it's in the process of being destroyed as a liquid, it can still flow, and it did. So you had an actual little flow of water on the surface of Mars, and we think Mars's surface is fairly porous. So when there is water on the surface, some of it gets, they say, sublimated up into the atmosphere, where it is lost to space for the most part. But some of it can also sink down through the surface. And that's a really cool thing about Mars. And this is one of the mechanisms that this image really helped support. The idea that there's still enough water on Mars in the surface, not on the surface, but underground and in some locations. You could have water, liquid water under the surface. Why not? It would have protection from the harsh atmosphere. And, when it hits the surface, that's where you get new gullies and little things forming. So liquid water, you know, is was now known to exist. You know, water ice was already well documented at the poles, and water vapor, of course, we could see little bits of water vapor, not much, mind you, but a little bit. But liquid water, well, that's necessary for life as we know it here on Earth, and the fact that it is on Mars under the surface, it really makes me wonder why we aren't trying to get under the surface more, but I understand drilling on other planets is hard. So this was a really big time in, you know, Martian exploration. I am a little bit of a Mars fan, so I was very excited when this came out. And the Mars orbiter camera on Mars Global Surveyor was actually the one that was used for this particular imaging, and the evidences of what they said call our new deposits. And it's quite interesting. So in order to see something on the surface, it lives for such a short time, you have to be pretty spectacularly lucky. But taking pictures of the entire planet regularly increases your chances by quite a lot. They mentioned that this discovery could have been some sort of surface frost somehow, or you know, some other kind of subsurface deposit that had just been very small. They do rule out the idea that it could have been anything dry. So it could not have been dry dust, because of the you know, dry dust that would have fallen down a slope would have appeared dark on the camera image and not light. So Mars Global Surveyor, while it was doing this, as I say, entirety of Mars, there are tens of thousands of gullies on slopes inside craters in other depressions on Mars. So most of the gullies are at latitudes of 30 degrees or higher. And the first discoveries of these little gullies was in 2000, the year 2000. So it's quite interesting sort of kickoff to this whole study of how much active liquid water can we find and where. Is it going to be all in these latitudes of 30 degrees or higher, or is there some more reason to be, you know, equatorial? So very, very fun. Mars Global Surveyor completed its primary mission in 2001, and it was in its third extended mission phase when it actually hit 2006, where it then failed to respond to any more messages and commands. So as of now, the mission has officially ended. So it officially was, NASA said, we're giving up basically in January of 2007. And we think it's still in a stable near polar circular orbit. So actually, one extra little side benefit was we actually created a very small artificial moon as well. So maybe we can do something with that.
Maybe in some distant future there will be Mars inhabitants originally from Earth working to like get it on again, like
Yeah, turn back on the
frequently.
Mars Global Surveyor. And hey, you know what though? If you do get to Mars, you're going to need some way of doing Martian GPS. So having a couple extra satellites isn't such a bad idea.
Maybe. It's weird. In my mind, that announcement was so much more recent than 2006.
Yeah, I agree with you on that one. 2006, I was like, 2006, but you know,
Sure?
yeah, it's when time and space do not always align in astronomy, especially when you're staying up very, very late at night.
Yeah.
So
Well,
I'll
I
go ahead
find
and
for me that ever since 2020, time has no meaning. So
yeah, that's true for many, yes.
yeah, everything either happened before or since. All right. Well, we're going to stay on Mars, but we're going to go 10 years earlier.
Woohoo! I love this one.
I know. And I was looking in our file that where we track all the this week in space and astronomy history pieces that we've done. It wasn't there.
Ooh.
Right? I can't believe it wasn't there. Maybe it was just missing. I don't know. Because okay,
Well,
now
time
people
to
are
update
wondering,
the
Julie, what are you
file.
talking about? Burying the lead a little bit. Okay, so December 4th, 1996 was the launch of the Mars Pathfinder mission. And so this was a NASA robotic space mission that landed a base station with a rover on Mars on July 4th, 1997, and maybe showed up in July. I didn't go check in our file. This is the second project in NASA's Discovery program, which was a new approach for NASA using low-cost spacecraft and frequent launches, the motto being cheaper, faster, better. The lander was called the Carl Sagan Memorial Station, and the rover was called Sojourner. Sojourner was named after the 19th century women's rights activist Sojourner Truth, and it was a name that was suggested by then 12-year-old Valerie Ambrose of Bridgeport, Connecticut, in an essay she submitted in the rover naming contest that was run by the Planetary Society. This was the first rover to operate outside the Earth-Moon system, and it landed in the Aries-Vallis region, and specifically in the, I don't know if it's Charisse or Carice, Planitia.
Oh, I always thought it was Carice.
I don't know. It's a
could be wrong.
CHR.
Yeah.
It could go either way. Because English. The mission carried instruments to analyze the Martian atmosphere, climate, and geology, and the composition of rocks and soil. And it was the first of a series of missions that included ever larger rovers, the first successful lander mission to Mars since the Viking missions in the 1970s. And it was also a proof of concept mission for the airbag-mediated touchdown with automated obstacle avoidance. The instruments included an alpha proton X-ray spectrometer, the APXS, for soil and rock analysis on the rover, 2 black and white cameras and 1 color camera on the rover, and 3 CCD cameras on the rover. There was on the platform a spectroscopic camera called the Imager for Mars Pathfinder, or IMP, and also the atmospheric structure instrument / meteorology package ASI/MET. And because it was spectroscopic, eventually you got to have things like the National Geographic publishing the red and blue 3D images with your 3D glasses, a la 10th Doctor.
Yes, and they had some
exciting.
really, really good ones. And I have to say, if you haven't looked up the Pathfinder panorama, at least.
Yeah.
That was an IMP one, right?
Yes, I believe so.
Yeah, and it's maybe one of the most famous images of Mars. It's just ridiculous.
So the lander entered the atmosphere and landed using a capsule, a supersonic parachute, and some solid rockets and large airbags to cushion the impact. Sojourner was released on Sol 2 and started investigating the local rocks that scientists wound up naming after cartoon characters like Barnacle Bill, Yogi, and Scooby-Doo. Here are some stats on Sojourner. It was a 6-wheel model, as I think all of the NASA rovers have been. It was 65 centimeters long, 48 centimeters wide, and 30 centimeters tall. So like, a small microwave or maybe a toaster oven. Compared to today's SUV sized rovers, it was a little wee one. It weighed 10.5 kilograms. That's about 23 pounds. Its maximum speed was 1 centimeter per second.
It was a great way to measure speed.
I know, right? Like, that's so slow. It's so sweet. It traveled approximately 100 meters in total, and not more than 12 meters from the lander platform. It was in operation a total of 83 sols. It sent 550 photos back to Earth and analyzed 16 locations. It sent back some interesting results. It confirmed past volcanic activity on Mars because the rocks were basaltic. The rocks showed wind erosion. There were some observations that determined the size of the particles in the pink Martian haze. In case you're curious, the radius is 1 micron. And there was support for the theory of a past warmer, wetter climate through the presence of iron oxyhydroxide. The mission was planned to last 1 week to a month, but it lasted nearly 3 months. And the last received transmission from Pathfinder was received on September 27th of 1997. The mission was terminated on March 10th, 1998. It's thought that likely what wound up happening is the onboard battery that was designed to last a month and was there to warm up the electronics and, protect them from the cold of the Martian nighttime, failed, and then that caused a cascade of failures from there.
Yeah, it did a good job, but it was a little tiny rover. And
but this is the first mission that I remember really paying attention to and really being aware of.
Yeah, and it did. I mean, it did still outlive its expected lifetime, so it did quite well. I mean, and it's worth remembering now. We've got Curiosity driving around doing all kinds of crazy stuff. This was very, very early on, and it was using very different technology in a lot of ways, and especially the landing system. If you haven't looked up the old bouncy ball landing system, if you've only seen the more modern missions or the sky crane and jets, it's really cool. But that did not exist before. And so to make this one work, they needed something that they could do at the time, and it literally was airbags, and it had to bounce along the surface and not die. And
it really is it reminds me of when you give a bunch of kids an egg and say, we're going to drop this from the second floor, protect it.
Right.
It totally has that feel to it. We're just going to wrap it up.
Yeah, well, and that's what they did. So it's a small little rover, right? A tiny little thing. Mm-hmm. Toaster oven, something, but the airbags are gigantic. The airbags are 4 persons standing on each other's shoulders high. The airbags were huge, and so they actually did have a solution that's not dissimilar to protect this egg, see what you can devise, kids. Just lots of cushioning and hope for the best.
And it worked. I mean, they used it.
Totally.
They used it
worked
several times later in other missions. It worked to a point where the rovers got to be too big.
Yeah, and it's that's once the rovers got to the larger size, they needed a different system. And these bounces, I think they had something 15 to 16 bounces on this one, and this lower gravity and very, very big bouncy cushions, and I mean it was bouncing up to, I think I saw something 15, 16 meters or 52 feet high. So that would have been it's too bad there was nothing watching it at the time, because we've gotten spoiled with high rise on Mars.
It's true.
Anyways, Mars is awesome.
Mars is awesome, and this mission was awesome. Um, and it just, I mean, it was the first in a bunch of NASA missions, but also a bunch of other agencies sending missions. Like Mars is just rife with robots now.
Oh yeah, yeah. Well, there's been a lot of success recently. Um, we've sent many robots, but still no humans as of yet. Although last I saw, they still had the Artemis next steps as on schedule for back to the moon. So
Woot woot.
who knows?
All right. Well, uh, just speaking of humans in space, let's move on to our next.
Yeah, I thought
piece.
that might I thought that might get us to our next This Week in Space and Astronomy History. Speaking of humans, wouldn't it be great to send humans to Mars? Well, sending humans into space is the first step. And so I'm going to go back to 1983. So mentally prepare yourselves for the time warp. 1983, December 5th, the first 6 Canadians are selected to be astronauts. And so this was, part of the Canadian sort of real space milestones. There have been a few very big events in Canada space history. Probably, I think Canadarm deployment would have been bigger, but I can't think of too many more that really captured people as much as real Canadian astronaut selection. Here are the Canadians that we're going to send into space. And that was Roberta Bondar, Mark Garneau, Steve McLean, Ken Money, Robert Thirsk, and Bjarni Tergessen. And I'm not sure I'm saying that right, but I'm going to give it a good try. So the selection of Canadian astronauts, and the initial Canadian astronauts that first came out, this was all part of our exploration of space in Canada. And this was basically due to a close collaboration between Canada and the United States in sort of 1974. And NASA actually sought out the Canadian expertise for the development of the robotic arm that would become, of course, the very famous and widely used now Canadarm. And then, of course, Canada was invited to participate in astronaut selection for space missions. So the first team of astronauts, that was 1983. So far, in addition to those first astronauts selected, we have now recruited 14 astronauts in Canada through 4 campaigns. And out of all of those astronauts, 9 of them have actually participated in 17 space missions so far. So this is a pretty big deal. So these people who are selected were one of thousands. So in the very first call, they already had more than 4,000 Canadians respond to the call for astronauts in 1983. And out of that, of course, not everybody can go, so only six were chosen. And basically, to be selected as an astronaut, as in this initial Canadian selection, you had to have what they said, exceptional academic background. So lots of publications, I suppose. Professional experience, you had to be very healthy. You actually had to pass some extremely rigorous physicals. Many of us would have trouble with those, I think. And I think even things like needing to wear glasses and things like that were considered. So it was very strict because, of course, early astronauts had to be quite robust, but also communication skills. So how many languages can you speak? Will you be able to communicate with everybody? So that was the start of the Canadian astronaut recruitment campaign. As I say, there were many more after the initial 1983 selection, there was one in 1992, and that was, I believe, over 5,000 Canadians applied and only 4 were selected. So this is where we got Chris Hadfield, of course. Very, I think he's still viral on social media for his guitar song. But we also got Mike McKay, Julie Piet, and Dave Williams. And since then, we had a third astronaut recruitment campaign, which you probably are a little more familiar of because we had Jeremy Hansen and David St. Jack. And of course, Jeremy Hansen is now, now the first Canadian to be entrusted with leading a NASA astronaut class. And, very much related to this Artemis mission that we were mentioning before, the idea of going back to the moon. So of course, Artemis 2, Jeremy Hansen will be on that mission. And fingers crossed for successful deployment on that, because if it succeeds, he'll be the first Canadian ever to venture to the moon. So as we go through the Canadian space milestones, we have, of course, December 5th, 1983, the first 6 Canadian astronauts are selected. And, Roberta Bondar, Mark Ganneau, Steve McLean, Ken Monet, Robert Thirsk, and Bjarne Trevessen. And I just have to give a little extra shout out to Steve McLean, who is a York University alumni. And that is, pretty cool. So he started out as an undergrad in the York actual, like, our real university. I'm not making this up. It's pretty cool. And he did, I believe he did physics and engineering, but I'll have to check on that. He then was selected as an astronaut and went into space. And his mission patch, I believe both of his mission patches are now in the observatory entrance at the Allan Carswell Observatory.
Nice.
So I can get back to I can 2 steps in astronomy. I can pretty much get back to the observatory no matter what, I think.
Nice.
But yes, it was pretty fun stuff.
The engineering department did not exist at York till sometime during the time I was there, 2000 maybe 2001.
So it must have been physics and astronomy then.
Yeah.
I'll have to just make sure to check that, because I know he was a major, but I think maybe it was just physics. He got his PhD in just physics.
There was also there was another program. It was like I can't remember what it was called, but it had to do with like satellite communication, that sort of thing. So maybe he took that. I don't know. Have to look it up.
I'm pretty sure it was just physics, but I do know he was involved with laser physics and optics. So that was it's pretty cool stuff. And of course, the LiDAR connection is only 2 steps away from that. And his missions, if you want to look them up, were STS 52 and STS 115. And I believe he was payload specialist on STS 52 and mission specialist on STS 115. And he did get to do a spacewalk. And he did have to wait until after Chris Hadfield, though. So he's the second Canadian to spacewalk. So lots of great Canadian astronaut history, all kicked off pretty much, on this day tomorrow, 1983.
Nice. I just looked it up. It was physics.
Oh, good.
Yeah, Bachelor of Science in Physics in 77 and a PhD in Physics in 83. And the other thing that I can add is that I had the privilege to meet Roberta Bondar when I was working at the Science Center, so 2011. And one of the first things she did was teach us how to properly say her name.
Oh, good.
It's Roberta Bondar, not Roberta Bondar, as everyone
Bondar.
So,
okay.
Yeah.
Noted. Noted.
Yep.
My
I figure
apologies.
since she took the time to teach me, I take the time to teach others.
Exactly. And that's exactly how it should be.
Yeah.
Um,
All right. So we're staying on the same day, December 5th, but we are moving to 2001 for our last item this week. And it is the launch of STS-108. This was a mission to the International Space Station flown by the Space Shuttle Endeavour to deliver supplies and to do some maintenance. It was the 12th shuttle flight to the ISS, and it delivered Expedition 4 crew and returned Expedition 3. While on station, the crew conducted one spacewalk to attach the Raffaello multipurpose logistics module to the station for unloading all the equipment and supplies that were in there. And then later, the module was returned to the shuttle payload bay to return back to Earth. An EVA was performed to install insulation on the mechanisms that rotate the ISS main solar arrays, and position 2 switches on the station's exterior to be installed on future shuttle mission that was mission STS-110. There were some slight changes made to the departure plans so that Endeavour could give the ISS a reboost in order to avoid coming too close to some space junk. There was a spent Russian rocket upper stage from a launch in the 1970s that would come to within 3 miles of the space station. And then the reboost made it so that the object only got 40 miles to within 40 miles of the space station, so much safer. The reboost, of course, used fuel. So instead of doing a full circle fly around before heading back to Earth, as the space shuttles usually did, Endeavour did only a quarter circle fly around. There were science experiments on board, and also science experiments returned back to Earth from the ISS. So the space shuttle carried home results from experiments performed during Expedition 3, the Advanced Protein Crystallization Facility, the Dynamic Controlled Protein Crystal Growth Experiment, and cells from the Cellular Biology Operations System Support System, or CBOS. And there were multiple, as I mentioned, experiments run. So multiple application customized Hitchhiker 1 or Mach 1 carried a wide array of experiments, including a prototype synchrotron radiation detector, the collisions into dust experiment 2, the capillary pump loop, and the space experiment module. The space experiment module carried experiments from Argentina, Portugal, Morocco, and Australia, as well as experiments from US school children. And on the way back, the space shuttle deployed a small satellite called Starshine 2 from a canister located in the payload bay. And more than 30,000 students from 660 schools in 26 countries tracked Starshine 2 as it orbited the Earth for 8 months. And the students who helped to polish the 845 mirrors on Starshine used the information they collected to calculate the density of Earth's upper atmosphere. STS-108 was also the first space shuttle launch after the 9/11 attacks. And so several flags, badges from fallen NYPD officers, patches, posters, and an emblem from the FDNY, patches from the Port Authority of New York and New Jersey were flown aboard Endeavour on that mission.
STS-108, all the way back in 2001.
Yeah.
Wow, time is weird. For
right?
Sure. I will say that one thing that does kind of tie this really well with what we've been talking about so far this episode is the this is all part of the exploration technology that we need to be developing if we are going to be sending humans out more into space, to the moon or beyond. And even in 2001, they're already doing a lot of medical research and studying how humans behave in space, how our bodies react to weightlessness, how we handle the higher radiation output that's up at that low Earth orbit. And I thought it was interesting that you mentioned the growing cancer cells as well as kidney cells to understand how not just how cell growth works, but one of the big dangers, of course, is if you are going farther out of Earth's influence, you go out of low Earth orbit to the moon, for example, you really don't get any appreciable protection whatsoever from the Earth anymore, and your radiation levels will be quite high. That's one of the big problems that astronauts will have if they are going to go to the moon and beyond. So, it's nothing. I suppose no research is ever wasted, but it's a really nice way to tie it together, I think.
Yes, absolutely. And I don't know, I guess it's easy to take for granted that we've had people living on the space station for 24 years almost now. It, you know, but like this was like the beginnings, right? They were just starting to run those long-term experiments. And also interestingly, the pilot was of this spacecraft, of this space shuttle, was Mark Kelly.
Oh yeah, yeah.
Who's, I think it's his brother, his twin brother, was the one who spent the year in space.
Yeah, they did the twin experiment. One of them went up for, there was he's
Scott Kelly.
Yes. Yeah. And one of them went into space for a year and the other one stayed on Earth.
Yeah.
And they were able to measure sort of the effect difference between them. And they're both fine, but
yes, absolutely. But they were able to measure. What's great about having twin astronauts is you have people who've gone through that rigorous training and testing and all that, just to become astronauts, like you mentioned, the physicals and all that. So you've got like baseline data on both of them, and then because they're identical twins, you can send one of them for a year in space, keep one of them down, and have a real control. I mean, they're still individual people, and there might be some different factors or whatever. It's not 100% perfect, but
it's as close as you can get, without cloning, right? So but it is very interesting. And I mean, this is why we know the decalcification of bones is such a problem. And we do know that there are permanent effects, that if you go into space for long times, you're going to lose muscle mass, you're going to lose calcium out of your bones. So if you're going for very, very long periods, one of the questions is, at some point, does it become impractical for you to actually come back to Earth gravity because it would be too extreme for you? But yeah, the International Space Station, as basically follow up to Muir, and a step along the way to what we hope will be, the Lunar Gateway. It has been part of a huge amount of development for medical and research and everything. So
yeah, it's amazing. Yay, space stations.
Yeah, it really is. a worthwhile. I think this is one of my favorite, sort of international collaborative efforts. It's like
Mhm.
if we can agree on nothing else, I'm surely we can all agree that this is awesome.
Yeah.
um, all right, so shall I do some little reminders?
Yes, please.
So just a reminder for everyone listening, we do have a little announcement. It is a winter time, coming up close on real winter time in Toronto. And that means that the sun sets very early. Our observatory tours are now starting at 5 p.m. So if you're looking at getting tickets for the in-person tours on Wednesdays, please be aware that the start time is now as early as 5. So if you weren't able to make it during the summer because of the late starts, here's your chance.
Mm.
We'll be keeping on that 5 p.m. time until until it gets a lot warmer.
Yeah, just remember your hat and your mitts and your coat.
Yes, mittens,
Mhm.
coats, boots, snow pants.
I mean, if you get that
You all know what to
chilly,
bring.
yeah,
I wear snow pants,
yeah.
but
Well, it's cold up there.
it is cold. All right. So
Okay,
that
let's
was
move on to
my
news.
yes. Do you want to do the station
Woohoo.
ID?
I mean, okay. I was thinking that, sure, why not? So you're listening to York Universe. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Head over to yorku.ca/science/observatory for chat, questions, content, etc., etc. And to do that, you will follow the links to OPV, or online public viewing. You are listening to myself, Julie Tomei, and Dr. Elena Hyde, and we've just finished our This Week in Space and Astronomy History, and we are moving on to the news. What have you got for us, Elena?
Oh, awesome stuff. And actually an extra reminder I just thought of, we should definitely tell people,
Okay.
is that if you're on that website and you do enjoy any of the free content that we bring you every week, you should consider doing your holiday shopping with us. The observatory now has the fabulous Allan Carswell Observatory 2024 calendars for sale, as well as t-shirts and coffee cups, and 3 fabulous poster designs and
Ooh.
postcards, and zippable tote bags.
Ooh.
It's pretty awesome. We've kind of got a whole store going on. The profits are not great. We try to price them as close to the cost to making them as possible. So they're awesome Christmas gifts, and it goes to support the observatory. So if you would like to help us buy new eyepieces and get some really cool stuff, it's all on that same website, and there's a little store area at the bottom that takes you to the York University bookstore, where everything is available online. Conversely, you can come on the tour and check that out there. So yes, I just figured you know what? It's close enough to the holiday season. I can advertise that we have
It's
cool things.
officially December. We're good.
Yeah,
These are nice posters.
they're really cool posters. Yeah.
Are these pictures
Um,
taken by staff?
yeah, all of the pictures are astrophotography of the Allan Carswell Observatory.
Nice.
Some are taken by students, some are taken by co-op students. Some of them I even help out with. So all kinds of things. So yes, very, very fun. Now in the news, we do have some fun astronomy news. I'll do mine first, and then I think we'll have enough time for both of them, Julie.
Sounds good.
So I'll do mine as a little bit of a sparkler. It's just a fun little discovery of a big planet. In fact, the planet is a little bit too big. The official title is Planet Too Big for Its Sun Throws Off Solar System Formation Models. So if you would like to find this article, it's on Science. So it was officially titled A Neptune Mass Exoplanet in Very Close Orbit Around a Low Mass Star Challenges Formation Models, which is actually very true. So the article itself, the full article does appear to be partway behind a paywall. So if you don't have a university with science article access, you might have a little trouble getting at it. But it's a pretty cool little discovery. So these folks were looking at, exoplanets. So these are planets going around stars other than our sun. So out there in the Milky Way, many, many, many stars, many, many, many planets. And the theories of planet formation as we know it say something like a cloud of gas and dust starts to collapse somewhere in space. And it collapses and collapses and collapses until a center basically gets so hot, it becomes a star. So it gets hot enough and massive enough to initiate fusion and becomes what we call a star. So that takes a lot of gas and a lot of collapsing before hydrogen hydrogen and helium, maybe a little bit, and trace things, can collapse enough to actually ignite in fusion. It's tremendous. Our star is tremendous. These things are ridiculous sized. So that's the process idea. And in this cloud of gas and dust that collapses, once your star turns on, it's going to start blowing whatever gas and dust is left out of the system. But in the meantime, little tiny differences in velocity cause it to kind of flatten down and rotate into basically a little disc shape. So sort of like a wheel tilted onto its side. And the gas and the dust that's in there will start to collide, and things that are going slightly more in one direction than the other will tend to survive. And so you end up with lots and lots of little collisions making bigger objects, and new planets can form. There's a couple different ways that people think this happens. Sometimes people think that maybe there might be some sort of gas collapse that triggers and you get sort of a fast planet formation for Jupiter-sized planets. Anyways, it's a whole fun batch of modeling you can do with hydrodynamics and stuff. But the gas that's left over from your star can form planets, but they're forming under very adverse situation, shall I say. And so it's thought that if you're going to make big planets, you need a big cloud of gas to collapse. And if you have a really big cloud of gas collapsing, well, it's going to make a big star. So how would you get a small star with a big planet? And that's the puzzler. So it's a nice, actually simple question. How do you get a big planet, which is about 13 Earth masses, almost the mass of Neptune, around a star that's a low mass star? And so they think that this particular star is 9 times less massive than our sun. So 1/9 the mass of our sun. And the planet is 13 times bigger than Earth. And its orbital period is 3.7 days. So it's close to this small star. This is not an expected outcome of any kind of normal gas collapse type of thing that we look at. So how did it happen? Could it have been captured somehow? Was it a runaway planet and it just happened to get captured into a close orbit? It seems almost unbelievably unlikely. So if you're going to try to model this, which was what they were proposing, they do what's called core accretion simulations, and basically close in Neptune mass planets are only formed out of that initial collapse if the dust mass is much bigger than what you normally see around a low mass star. So how do you get a lot of dust collapsing and still make a low mass star? I mean, I can think of some ways, but it's an interesting puzzle. So that's the puzzle, and that's the news, and now you all know about it.
Nice. That's what's
um,
great about astronomy. There's always little puzzles that
oh
pop
yeah,
up.
it's all about the mysteries, right? And you've got a pretty good one too.
I do. So a protoplanetary disk has been found in another galaxy. Dun dun
Ooh.
dun. Um, so dozens of protoplanetary disks have been imaged in the Milky Way, and that in itself is actually kind of amazing. You'll find out why momentarily. But now one has been found in another galaxy. So the discovery was made using the Atacama Large Millimeter Submillimeter Array, or ALMA, in Chile. And it detected the spinning disk around a massive star in the Large Magellanic Cloud, the one of the two companion galaxies to our own, about 160,000 light years away. The study was led by Anna McLeod, an associate professor at Durham University in the UK, and she led a team that was doing a follow-up study on a system called HH1177. That in 2019, using the Very Large Telescope, or the VLT, they had observed a jet emitted by the young massive star. HH1177 is 12 times more massive than the sun. This was the first time a jet was observed at visible wavelengths outside of the galaxy, since usually these objects are obscured by a whole bunch of dust, because these are newly forming stars and they're in areas full of gas and dust. This jet that they observed is nearly 33 light years long. It's one of the longest ever observed. And the jet is a clue that you'd have one of these accretion disks, these disks around the star where planets may or would be forming, starting to form, or would form soon. And so the team needed to measure the movement of the dense gas around the star to see if there was an accretion disk there. So the motion of the gas indicated that there is radial flow of material falling onto a disk-like structure, and new observations found that the disk exhibits signs of Keplerian rotation. In other words, the disk obeys Kepler's laws of motion because of a dominant massive body at the center. So matter can't fall directly into a growing star. As Elena mentioned, it flattens out into a spinning disk. Physics just works like that. And the disk spins faster closer to the center than to the edges. And then the difference in speed tells astronomers that that is an accretion disk and that it exists where you're looking. The Large Magellanic Cloud is different from the Milky Way in that the stars that form there have lower dust content. And so HH1177 was not cloaked by its early dust cloud. And so that's what made it possible to observe it, as well as the high sensitivity and high angular resolution instrumentation that's available at ALMA.
Very fun.
Yeah.
And it is worth mentioning is, it's another galaxy, but it's also one of the closest other galaxies to the Milky Way, because the distances involved when you start
pretty
talking
small,
about
relatively
galaxies.
speaking.
Yeah, it's the angle subtended on the sky of these things is absolutely mind-bogglingly small. And the LMC, the Large Magellanic Cloud, is a great place to look for things on a large scale that you might have trouble seeing in the Milky Way. It's actually, in addition to this, which is star formation, it's a very good place for looking at supernova remnants too.
Yes. Yeah, more often than not, when you see like this has been observed in another galaxy,
Yeah.
like is it the LMC? It was the LMC.
Or
I mean,
the
it's not
SMC.
always, but you know.
I will say notable shout out and exception to the Pandas survey, which has been doing amazing work in the Andromeda Galaxy. And with that, we should probably encourage people to go read those articles. They're really fun.
Yes. All right, everyone. We are on the hour. That went by so quickly. You've been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been myself, Judy Tomei, and Dr. Elena Hyde. You can always contact us on Twitter at our handle at York Universe, Twitter, X, whatever, Instagram at York U Observatory, and Facebook at Allan I Carswell Obs. Check out our website, yorku.ca/science/observatory for all the fun things. Thank you for tuning in to York Universe. Clear skies and have a good night.
Good night, and don't forget to do your holiday shopping with the observatory store now up on that same website.